Yes, where did all this data came from? Hello?
Hello, sir.
I said, where did they come from? 51, 77, 27, and 46.
These are the sample values.
From where?
Okay, let me show you where the sample values came from. They were drawn from the sample pool.
Full of where?
Okay, they were drawn from the sampling number, sorry.
Where? From where? I just need to
Ta-
hear something. From
Table 8.3 from the table 8.3.
8.3. Where
Yes.
is table 8.3?
Sorry, from appendix 9, they were drawn from that table.
Yes, that's what I want to hear. They are drawn from Appendix 9. So you'll be given that table in what? In exam. If you are told to use it, the table will be given to you. That's how all these numbers were drawn. Can I go on?
Yes. Yes.
Okay. Give me some. Okay. Any question? Any question?
No question, no.
Okay. Now, the next thing is to move all the things we have done so far is we've calculated sampling distribution using the mean, the sample distribution of what? Of means. Now, I want to calculate the sample distribution using that of proportion. Using that of proportion. Let me recap what I said regarding that yesterday. I can rub up this.
You can rub it off, yes.
Kí ni nǹkan náà? Kí ni? What happened? What happened? Go on it now. You have the outfit, right? The villain has outfit. You know how long you know why you hear of it.
Between single ones, so
Don't worry. That's my love back there. Don't worry. Hello, Shay.
yes.
Okay. So we want to take the one for proportion. When you look at the ones we've been taking so far, they are the one for mean. So let me recap again. Let me recap again so that you know what I'm talking about. Remember, from the beginning of this topic, we talked about uh, sampling with what? Hello, Shay.
Yes.
So we talked about mean. This is the population mean. When you're talking
Yes.
about sampling distribution of mean.
Mhm.
So your mean is this, and your standard deviation is given by what? Sigma over root of n, right?
Yes.
Mhm. We said when we have it to be, what? Without replacement, this formula will change. This formula is for with what? With replacement. So for without replacement, I'm trying to recap everything. This one will change to what? Sigma over square root of n, square root of what? Np minus n over what? Np minus 1. I made mention of that, right? This is for without replacement. We have applied it.
Yes.
That's why you will need some assignment on this. So now we also have the one for proportion. We have the one for proportion. That's where I'm going now. Sampling distribution
Yes.
of proportion. So the one for proportion is where I'm going now. But let me write out the formulas again for proportion. For proportion, I said all that you would do, mean is NP, right?
Yes.
I said when you get to NP, mean is NP, where your P is your proportion, success and failure. You can see what I'm writing
Yes.
here, right?
Yes.
Then your sigma is what? Square root of what? NPQ, right? Then for
Yes.
proportion, sampling distribution of a proportion. Divide your mean by what? Divide your mean by n. Divide this one by n. You have your mean to be what? You have your mean to be n. Your mean equals to your n. And your mean equals to your p, right?
Yes.
This cancels this, isn't it?
Yes.
Then for the standard deviation, square root of what? NPQ divided by n. You have what? PQ over what? Over n square root. Isn't it?
Yes.
So these formulas now is what I've been using for proportion.
Yes.
I'll be using this formula for proportion. So let's take it one after the other. Now, remember, I also told you that, I think I said that yesterday, we have for discrete distribution. And we have what? Continuous what? Distribution, right?
Yes.
So can you give me an example that I illustrated using continuous distribution? I gave you some examples on how to know that. I gave you 3 on how to know when to apply continuous distribution. Can you remember? If you can't remember, tell me you can't remember. Let me cite it again.
Can I remember what?
I said we have discrete distribution, when to apply discrete distribution and when not to apply discrete distribution. When do we call a distribution as discrete and when do we call it as continuous? I said I gave you an example of the continuous distribution. In what case do we apply a continuous distribution? I gave you 3 examples of such cases yesterday.
Yeah.
Can you remember?
Continuous distribution. Okay, no, I don't recall. Can you refresh my memory?
Okay, I'm coming. Now, I told you about using a fair coin, right?
Yes.
A fair coin can have a success or failure, right?
Yes.
It cannot change half and half. It's either a head or a tail. Then I gave you another one as what? A die. A die, a 6 appearing is 1/6, isn't it?
Yes.
A 4 appearing is still 1/6. It doesn't change, right?
Yes.
Why the last, but this one may not often be used. Then this other one is what? A boy or a girl. In a family, they are looking for a boy or a girl. It can't be an hermaphrodite on a normal case, isn't it? It's either he's a boy
Yes.
or a girl. So probability of the success and failure is what? 1/2, isn't it?
Yes.
So those are the three cases of example that I illustrated for you. And I said if it is continuous, in such case, if you are giving the value of x, probability of x to be maybe 64. If you are giving the value of x to be probability of x equals 64. Once you see that they are citing these examples, and you need to calculate the standard score. You need to calculate the standard score. You know what I mean by standard score, right? Z, x minus mu over standard deviation, isn't it?
Yes.
If you need to calculate the standard score, I said once you know that what is a continuous distribution, all you need to do is to remove 0.5 from this value. Are you with
Yes.
me?
Yes.
But if you are giving the probability like maybe probability of 64 less than equals to x, maybe less than 79. All you need to do to get the value of it, this one will be what? 63.5, isn't it? From 79.5.
Yes.
Do you get that?
Yes.
So take note of these three things in this example that I will illustrate now. So though I will apply, the method I will apply for you is the one for the discrete and the one for the what? Continuous distribution. So I'll be applying this method of sample distribution of mean, and I'll also be applying this method of what? Sample distribution for proportion. I'll be using the two examples simultaneously to solve question on this. Can I go on?
Yes.
Okay, that will be the last question for today. Please don't forget this. I won't repeat it again. I assume you do not need to. Maybe you
Okay,
write
wait,
it
let
down.
me.
Maybe you write it down.
Okay, can you show the thing so I can write it down?
This one, right? Is it this one you're
Yes.
writing? Which one? This one, right?
Yes. Yes. Move the camera there so I can see everything.
Is it okay now?
Hold
Can you
on.
see the entire board now?
I can almost see it. Wait. Chill, hold on. I can almost see it.
Have you seen it?
You said fair coin.
Die and the borrow you for continuous distribution.
Mhm.
When you are done, you let me know.
Yes.
You are done, right?
No, I'm not done. I'm not done. Just I said yes, I'll let you know. I still can't see everything, so
Where? Should I tilt off?
it says
Should
fair
I
coin is
tilt
equal
off?
to P equals 1/2 and Q is equal to what?
1/2 now. There are success and failure. 1/2. 1/2 for success, 1/2 for failure.
So I said fair coin is equal. Oh,
Fair coin. It's either a head or a tail, isn't it? Isn't
yes.
it?
Okay, so I can't see it. Can you move it there? I can't see it.
Where?
Down where it says fair coin and die, I cannot see it well.
What about this way?
Yes, I can see. Yes, I can see now. It says what's on that die? It says big origin.
I'm not writing this for failure. I said this one, you may not consider this, but let's consider this and this. But just put fair coin die and a boy or a girl. P equals to 6. Nothing is there. Can you see my hand?
Yes.
Mm-hmm.
So it said boy or girl is what? It says P equals to what?
Half And Q equals to half.
Okay, Q equals to. Okay, no problem.
Okay. I
I'm coming.
can
So I
go
want to
on.
quickly use the. I want
Oh,
to
yeah.
quickly use the restroom. I'm coming back.
Okay. All right. All right. People are- I only want to tell you this. So eléyìí bẹ́ẹ̀ sọ̀rọ̀ kékeré téèbù ló máa fi generate paasi ọ̀fọ̀ pé fọ́nfọ̀ lẹ́ńtìsì téèbù wá sí pé paasi wọn nọ́mbẹ̀ according to wọ́n ń kà 1 2 3 4 5 6 7 8 9 wọn nọ́mbẹ̀ first one yẹn 1 second one yẹn 2 first one
Okay,
yẹn
so I'm
first
back.
person will generate 1 it will get
Okay, I'm
second
back,
and
sir.
6 one will get 30.
So I'm back. I'm back. I'm back, sir.
Okay. I hope my class is not boring.
No, it's not boring. It's not boring. It's not boring.
That's the way math, you just need to wrap your head around it until you. Okay. Can I continue now?
Yes.
Okay. Find the probability that in 120 doses of a fair corn. Now, the question will not tell you any method to use. You are the one to adopt a method. Are you with me?
Yes.
You are the one to adopt a method that you feel deem necessary. So any method you use, just know that just ensure that you're applying the right method. So I'm rubbing off this. Now find the probability that in 120 doses of a fair corn. So what should come to your mind is that what this question is telling you to what? To use is an aspect of continuous distribution, right? Because they said a fair corn, right? Hello, Sheyi.
Yes.
They said a fair coin, so you should know that the idea of a continuous distribution should come to your mind. Find probability that in 120 pieces of a fair coin, less than 40% or more than 60% will be heads. Are you there?
Yes.
Okay. Now, it's like you are distracted though.
No, I'm here. I'm here. I'm here. I'm here. I'm here.
So we are looking for probability of heads. They said is what? You see that is 40%. 40% is 0.4. And 60% is what? 0.6, isn't it?
Yes.
I believe you can see the board.
Yes.
Zero 0.4 less than X less than 0.6. That's the meaning of the 0.4 less than X less than 0.6. Can I move on?
Yes.
That's what we are told to do. Now, if I want to calculate this, what is my mean? My mean is NP, right? Total number of doses
Yes.
is what? What the total number of toasts is 120, right? Isn't it?
Yes.
Now, for me to get X, now, I don't want to use, I'm going the direction of proportion, but let me calculate the one for mean first. Let me calculate the one for mean. So 120 times P here is what? This 40 over 100. 40 over 100 is what? 48. Are you there?
Yes.
So I have to write 48 here, but let me still write it. I'll rub it off later. The other one is 120 times what? 60 over 100. That would be what? 72, right?
Yes.
72. I'll write 72 here. Are you there?
Yes.
Now, 72. Now, I will come here. Since I said it's a continuous what? Distribution. It's a continuous distribution. I'm going to remove 0.5. That will be 47.5, right? And 72, I'll have 7.5 to it. That's what I'm calculating. Is this one clear?
Yes.
Then I will calculate my standard score for this, generate standard score for this. So the graph will be like this. So the first thing is to calculate my Z. Remember the formula for Z is X minus mean over standard deviation, right?
Yes.
So what is my X? 47.5. What is my mean? What's my mean?
Your mean is
You come back again. Mean is what? NP, right?
yes.
So success and failure. This is 120 times success and failure, 1 over 2. That's how to calculate that. Don't confuse it with your
Yes.
X. Don't confuse it with this X. This particular P here is representing your success and your failure. Do you get that?
Yes.
It's representing your success and your failure. So this one is what? 60, right?
Yes.
So your sigma is what? NPQ. Square root, isn't it? This by 120 times half times half. When you do that, you get 5.48. Can you confirm that?
Yes.
Okay, 5.48. You agree with it? Do you agree with
Yes,
it?
I agree with it.
So substitute the mean now. Mean is 60. Standard deviation is what? 5.48. Are you there?
Yes.
Okay. So you get me the value of Z. Get me the value of Z. You do the same thing for this. Z is what? 72.5 minus 60 over what? 5.48. Give me the value. Give me the value. Now, as you're giving the value, you just be listening. You will see that this particular question is talking about values for that are large. You see that we are considering n to be 120, large values. That is where this normal distribution is useful. For large values, Poisson may not take care of that, though it has its own effect as well. But normal distribution is normally used when the values are large. When we're taking binomial, we're only treating like maybe up to 10, maybe up to 5, up to 6. We are not taking large values. Once the number becomes so large, like 120, 30, 50, normal distribution will take care of that. Give me this value.
The
Are
value
you
is 2.28.
2.28.
Yes, for the
Plus or
second one.
minus, plus or minus. Second one,
Plus.
2.28. The first one. The
Well, let
first
me
one
check for the first one. 47.5 and 60. It's also is negative is minus 2.28.
2.28. Good. Now that is what we'll check on the graph, right? 0, isn't it?
Yes.
I'll put 2.28 here, right?
Yes.
I'll put 2.28 here. Where will I shade?
Yes.
Where will I shade?
You will shade from negative 2.28 to 0 to 2.28.
Good. I'm going to shade this. So how will I calculate it? You check the area under the curve, right? You check the
Yes.
area under the curve. I love the way this class is moving. You check the area under the curve, right?
Yes.
So give me the values. Just check for 2.28. When you check 2.28, area under the curve, what are you going to do?
Okay,
Check
you're
it.
going to add both of
Check
them.
it. I'm going to add what?
You add two of them.
Good, good, good. That shows that I've thought. That's good. Give me the value.
2.28 is going to 0.4887.
Have you off the have you on it back? What you told me that have you on it back? Is it on?
0.4887.
I hope it's not sounding
I don't know.
When I get like,
Oh God, I don't know. I smell like I don't know. When I get positive feedback, I always smoke. I can't help it. Whenever I get positive,
what's the value?
0.4887.
So 0.4887, right? So I'll
Yes.
multiply by 2, right?
Yes.
Check it again. You didn't get the value.
Wait, sorry. It's not 0.4887.
You are checking 2.28.
Oh, sorry. 2.281. Is it not meant to be 2.28? I'm checking.
Yes, 2.28.
Yes, now 2.2.
Will I come and check? Where are you checking now?
Wait, what are you getting? Is it not 0.48?
Area under this curve. You check 2.2 under 8. Under the normal curve.
2.2 under 8. Yes, now 0.4887, is it not? Oh, under the normal curve, 0.4887. So what are you getting?
I'm coming, just calm down. Okay, good. Don't worry. Look at the question again. The question says you should get less than 40. So that means this particular one I've just written is what? Probability for what? Can you interpret this one? Can you interpret this one? Can you interpret the question? What I've just written is for between 40 and what? And 60%. This is the interpretation, right?
Yes.
But the question says I should get, look at the question A again. Look at question A again. It said get what? Less than 40. That means I'm getting X less than 40%, isn't it? And what? Probability of X greater than 60. Is that not?
Yes.
So if I will get probability of X, yeah, this is what I will get. I'm going to put 48 here. Then I'll put what?
Yes.
Isn't it?
Yes.
Isn't it?
Yes.
So this curve will change, right?
Yes.
So it is the value it is this curve that will change.
Yes.
So that means where will I shift now? Using this probability of x less than 48, probability of x greater than 72. Where will I shift?
You shade under the you shade from negative 2.28 to positive 2.28.
This side or this side?
Wait, what are you asking? Which one do you want to shade?
See, x less than 48. Where will I shade?
You shade from 2.28 to the end.
Like this, right?
Yes.
Okay. Then this one, go.
Same thing from
Same
2.28
thing.
to
Oh
the
yeah,
end.
let's get this one now. Let's get this one.
Okay.
Tell me what I'm going to do before you go ahead. I know you have gotten the value. What value did you get?
0.4887.
0.4887, right? So for me to get, that means 0.4887 is from where to where? Zero point four eight eight seven is from where to where? See, 0.4887 is from where to where?
From 4887 is in the middle from
From here.
2.22.
Good. So how do I get from this particular place to this place?
From 4887 from here to here. You have to subtract what's it called?
0.5,
Subtract
right?
it from 0.5.
Good, 0.5. Then I'll multiply by
2.
Do you know where the 2 is coming from?
Because it's the same on the other
The
side.
other side. Good, good. Ah, good, good. So remove that. What do you get now?
You have 0.0226.
I'll have 0.0226, isn't it?
Yes.
So I've been able to apply the first method. Any method you like, you use. So I've been able to apply the sampling distribution of mean method. And that is what warranted this. Are you there?
Yes.
So let me complete the question. The other question says you should find the probability when it's 5/8 or more will be x. I believe you can see my hand. Find probability when it is 5/8 or more.
Yes.
So how do you interpret that? That would be this, right?
Yes.
So what will I do? You go ahead with the same way. You solve it with the same method. So I want to apply the same method. I don't know how I will compare the two values for you, but you have it in your PDF, right?
Yes.
So what we're going to do is to calculate. We have calculated the mean already. You don't change that one. Mean is 60. Standard deviation is what? 5.48. That doesn't change. The only one that changes is your P, the value of your P, which is 5/8. 5/8 times what? Times 120. This one I'm solving is not in your textbook. Oh. It's not in your
Yes.
textbook. Just I don't know how you're going to jot it down. So just find a way to jot it down. So this is the value of your x. So what's the value? When you do this, what do you have? You have 75, right? Multiply this,
Yes.
what do you have? Do you have this when you do that?
5/8 and 120. Yes, I have it.
So your value of mean doesn't change. But only this one will change.
Yes.
Okay. Now, they say we should calculate for x greater than 5/8. That means you are substituting this to be px greater than 75.
Yes.
Sorry for writing 5/8. So to 5/8 times 120. So that will give me 75. So let me calculate for z again. Z will be x minus mean over standard deviation, right? So
Yes.
this will be 75. Now, because it is continuous, because it is continuous, we don't know. Now, once it is greater than, hello?
Yes.
Once it is greater than, you will come down by removing the 0.5. You know, the one we did here, we are, where is it? The one we did here is because it's having between. That's why I can remove 0.5 in this one and remove 0.5 and add 0.5 to this one. Are you with me?
Yes.
When you turn this x, you turn it this way. When you turn this x this way, you know it will be x greater than 47.5, isn't it?
Yes.
You see that the lower one, you removed 0.5, isn't it?
Yes.
When it is greater than, you remove 0.5. This one, when you turn this one is by writing x less than 72.5, isn't it? This one, you added 0.5, isn't it?
Yes.
The same concept here as well. The same concept here as well. When it is greater than, when it is greater than, when it is greater than, you what? You remove 0.5. Are you there?
Yes.
You remove 0.5. That's why I'm going to have 74.5 because it's a continuous distribution. Minus mean is 60. Standard deviation is 5.48. Give me the value. It's not in your book. Oh. This one is not in the book. Oh.
Okay, let me calculate the value minus 60 over 5.48.
Quickly.
The value is 2.65.
2.65, right? So you check the graph.
Yes.
Use the graph. Greater than what? Where will I put it? I'll put it here, right? And shade where?
Yes.
I'll shade this side, right? I'll shade this side, right?
Yes.
So get me the area under the curve. Get me the area. Area will be what? Get me the area.
Area under the curve for 2.65.
Yes.
That's going to be 0.4960.
0.4967. What will I do? Am I done with the calculation?
You have to minus it from 0.5.
0.5, yes. So what will I get?
0.5 minus 0.496.
So what's the value?
0.4. Sorry, 0.004.
0.004, which is the same thing as when you use proportion. So this method now, I just imported this method for some